Now I'm going to return to the graph of lift versus angle of attack shown here. I'm going to use this graph to explain the different airspeed limits. First, let's assume that our hypothetical glider weighs 1,000 pounds, shown by the blue line. You can now see that the lowest airspeed that will produce 1,000 pounds of lift at the critical angle of attack is 50 knots. This means in this case that the stall speed would be 50 knots. Now let's assume that this glider has a load limit of 4 Gs as shown here by the orange line. So if the lift is more than 4,000 pounds, the glider could break. Notice that at 100 knots, the amount of lift that can be created just reaches 4,000 pounds at the critical angle of attack. This then would be the maneuvering speed, since below this airspeed, it's impossible to overload the glider because it will stall first. However, above this speed, you have to be careful how much control movement you use so you don't overload the glider. The range between the stall speed and the maneuvering speed is called the normal operating range, as shown here in green. This glider will start to flutter at 125 knots. Again, this is true airspeed, not indicated airspeed. This airspeed is shown in red and should not be exceeded no matter what the angle of attack is. The range between the maneuvering speed and the VNE is called the caution range and is shown here in yellow. Any airspeed above 125 knots or any combination of airspeed and angle of attack that will give you greater than 4,000 pounds of lift is shown here by the red hashed area. Flight in this area is not permitted. Now let's take a look at what the airspeed indicator for this glider would look like. The green arc, from the stall speed of 50 to the maneuvering speed of 100 knots, is the normal operating range. The yellow arc, from 100 to 125 knots, is the caution range, and the red line for VNE is at 125 knots. But remember, this is only the VNE at sea level, and it decreases as you climb.